Hello, my name is METİN Arıdaşır. This is 135th part of explanation of my theory. According to my theory and my formulas, if the electron mass was really 9.11 × 10⁻³ kilogram, particle accelerators would have destroyed all atoms. 1. Here snapshot. First page that I wrote. I hope you see. One, 91.155 nanometer wavelength size at rest, electron motion forms, C direction, mass is 2.42 10⁻³ kilogram. Linear velocity component mass is 3.858 10⁻36 kilogram, according to my theory and my formulas. Whereas, in accepted physics theories, electron's mass is constant, single, and equal to 9.11 10⁻³ kilogram. 2. There are different wavelength size kinds of electron motion forms in universes. Don't forget, most common wavelength size kind of electron motion form is lambda n initial wavelength, lambda n equal to 91.155 nanometer wavelength size kind electron motion form in our universes. 91.155 nanometer initial wavelength size electron motion form is the constituent part of all known atoms. 91.155 nanometer wavelength size electron motion forms can shrink or enlarge while connecting with multi-protons by following Arıdaşır's mine. E n alpha is equal to h c divided by n square lambda n minus delta lambda cosine alpha formula and mine other formulas. Whereas in accepted physics theories, electrons are point-like, dimensionless particles. Whereas in accepted physics theories, electrons are point-like, dimensionless particles. 3. Electron motion forms are unique sources of light in universes. And if an electron motion form is free, it produces and propagates successive waves. While doing this, it doesn't need accelerating or decelerating or being in motion in any way. An at-rest free electron motion form can propagate the light. Whereas, in accepted physics, an at-rest charged particle, including electron, cannot propagate light. 4. If an electron motion form gains velocity, wavelength, wave velocity, point masses, point energies of its successive waves vary depend on its velocity, its motion direction, and its orientation. Here, the light source is the electron motion form. Whereas, in accepted physics theories, light speed is independent of its source's motion and source's velocity. Yes. This is my first page. Now, here, please snapshot. Please notice my ratings. I hope you see wholly. Yes. If an electron motion form gains velocity, wavelength, wave velocity, point masses, point energies of its successive waves vary depending on its velocity, motion direction, and orientation. Here, the light source is the electron motion form, whereas in accepted physics theories, light speed is independent of its source's motion and velocity. 5. Now, if an electron was 9.11 10 to the minus 31 kilogram, if an electron was 9.11 10 to the minus 31 kilogram, its at rest situation wavelength would be equal to lambda n 0.0024234 nanometer. According to my formulas, its lambda n will be that 9.11 10 to the minus 31 kilogram electrons at rest initial wavelength. Okay? N equal to 1, delta lambda cosine alpha 0. Then this is the result for at rest point mass. 6. Think of that. We will make this lambda n 0.0024234 nanometer at rest wavelength size electron gain near the speed of light velocity by applying voltage on it to head-on collision with proton. Think of that. Please read this page. Now we assume as accepted physics what will happen if an electron was 9.11 10 to the minus 31 kilogram. Its initial wavelength would be 0.0024234 nanometer. Think of at rest wavelength is that, but according to my theory and my formulas, when we apply voltage on the electron motion form to make it gain velocity in the motion direction, in the z direction, its wavelength will be shortened wavelength, will be narrowest wavelength. What will be here? If we make this 0.002423 nanometer wavelength 9.11 10 to the minus 31 kilogram mass electron gain velocity near the speed of light, what voltage we need and what will be shortened wavelength in the direction of collision, colliding, 0 degree, in the direction of accelerated electrons motion. What will be wavelength. This is so important. Yes. Third page. To do this, snapshot now again. Here. I advise you to notice that page that I wrote. To do this, we must apply. I computed according to my theory and my formulas. To do this, make this electron gain near the speed of light. Velocity, say 298,000 kilometers per second. Accelerated electron's velocity by applying voltage, say. To do this, we must apply 77.24684 megavolt voltage on 0.00242 nanometer size electron that assumed at rest mass is 9.11 10 to the minus 31 kilogram as accepted physics, but wrong we know, I know. According to my formulas, lambda n minus delta lambda, this 1248 nanometer volt divided by voltage is equal to delta lambda divided by lambda n electron velocity. These two formulas, that formulas, mine formulas. Okay. I computed delta lambda, and I know lambda normal, and lambda n minus delta lambda will be 0.000016, 15, 60 nanometer here. Notice, please. So small. We will see now what will happen. What would happen if electron's mass was 9.11 10 to the minus 13 kilogram? Yes. Voltage, applied voltage, 77.24684 megavolt. Okay. 77.24 megavolt applied voltage accelerated near the speed of light. Electron motion form shrinks in zero direction to shortest shortened wavelength. Then lambda n minus delta lambda here would be 0.00016, 15, 60 nanometer through the proton for colliding. Yes. Fourth page that I wrote, snapshot, please notice that. I hope you see wholly. Yes. Seven. Now think of that with 0.00016, 15, 60 nanometer shortened, zero direction, wavelength electron will meet with, for example, up quark of proton. In my previous video, I have explained that successive waves linear velocity direction component makes proton-bound electron separate from the atom. For to do this, same wavelength successive waves or smaller wavelength successive waves were enough to separate bounded proton bounded electron. Now, like this, each other bound quarks, free electron motion forms successive waves may one of these quarks or these quarks separate from them. Like this, remember from my previous video. Okay? Same wavelength, imbalance, separating. Okay. Okay. Now, in my previous video, I have explained that successive waves linear velocity direction component makes proton-bound electrons separate from the atom. To do this, same wavelength successive waves or smaller wavelength waves were enough. According to me, quarks are electron-like. Quarks are electron-like motion forms that are connected with each other by making joint motion. Their lambda normal initial wavelengths are much more smaller than ours. If quarks were free, I think quarks are each quark is electron motion form, electron-like motion form. If a quark separated from their joint motion, if a quark is a free, it produces and propagates successive waves like our electron motion forms, like all of electron motion forms. Yes, if quarks were free, they would produce and propagate successive waves, and their successive waves would make all our atoms, electrons, separate from all protons wholly. This would be a catastrophe for our universe, for our habitual universe. Here. Universe is goes to go on, but our universe would finish. Yes, fourth page, snapshot. Then fifth page. For example, snapshot again. Subject is important, I guess. For example, an up quark mass is 3.5 10 to the minus 30 kilogram, and it made joint motion with other quarks. If it is, I think so, electron-like motion form, its ground state, say, wavelength or initial wavelength, will be equal to lambda n quark, up quark, is equal to 0.00630793 nanometer. Here. Okay. Pay attention. Smaller than accelerated assumed 9.11 × 10⁻31 kilogram mass electron. Okay? If electron mass was 9.11 10⁻31 kilogram, at this speed, 298,000 kilometers per second velocity, electrons' shortened wavelength would be greater, it would be so much smaller than quarks ground state wavelength. 0.000016 electrons, shortened wavelength, they will meet and interact, and quarks lambda n 0.000063, smaller than electrons. Okay, don't forget this. This is my computing here. Then, what would happen then? Coming electrons to collide with proton, up quark including, at 298,000 kilometers per second velocity with its shortened lambda n minus delta lambda 0.0000161560 nanometer wavelength. That is 39.043 times smaller wavelength than up quarks lambda normal, which is equal to 0.00063 nanometer wavelength. Then there would be linear velocity faster than light component interaction, not particle-particle colliding interaction, between these two, up quark and accelerated electron motion form. Snapshot. Notice please. 6th page. Snapshot again. At the end, yes, what would be happened at the end? At the end, 0.00001615.6 nanometer size electron motion form would make 0.00063 nanometer size up quark separate from quarks joint motion proton. Therefore, free up quark would produce and propagate waves, successive waves at this wavelength to ionize, to destroy all of known our universe atoms. This catastrophe is not actualized because of the electron's mass is not 9.11 10⁻31 kilogram. In accepted physics theories, electron mass 9.11 10⁻31 kilogram is wrong information. Our universe's electrons' initial wavelength is 91.155 nanometer and at rest masses are 2.42 10⁻35 kilogram and 3.858 10⁻36 kilogram.